Okay, so I'm sitting here learning verse, but I'm gonna go back and we can learn it together, y'all, because I don't want to leave y'all out the loop. So let's go back to, I think, the lesson two, lesson one. We can go to the beginning. So basically, lesson one. The first step is to make sure you have good enough understanding of basic programming terms. Now, this goes over a lot of basic stuff. So it's like if you've already been coding, you kind of know what a lot of this stuff is. But we'll go over some of it here. Program, we know what a program is. A verse is the programming language that we're about to learn today together. Um, Compiling, this is all stuff that we know. Algorithms, we've heard this before. They give you a little practice algorithm, test algorithm, basically make up a set of instructions. This is what the algorithm is. Source code versus machine code. Source code is the code that humans create and can read. Machine code is the code that gets, or the code, source code gets turned into machine code. And machine code is only read by machines, computer language. Execution, errors in code, talking about compiling errors and bugs. What else do we got here? Okay, so this is very similar to, it looks like C++ or any other language. So we've got the brackets here. It's showing us a little bit, but it's still going over just basic terms. Bugs versus compiler errors. They're saying this is a correct expression right here. The same expression written with the bug, and it's because the 1 is there versus the 0. So that's basically the first page. It just told you a whole bunch of terms. But I want to jump into the hard stuff, because like if you know coding, you know the coding. This is probably not. I'm not doing this for people who are just starting coding. I'm doing this for people who've been in Unreal maybe, or maybe just in Unity or whatever, and want to jump into this. But if you're in Unreal, it's obviously going to give you a slight advantage. Anyways, they ask you in this lesson to write an algorithm to how to catch a mouse, and you simply put the instructions together. So let's go to the next lesson. Time to look at some elements that make the code work. Alright, cool. This is where we start to learn. Expression. Expression is the smallest unit of the code that produces a result. For example, 1 plus 2 is an expression that gives out an output of 3 when the program runs. So you could just say print, parentheses, quotations, curly brackets, 1 plus 2, and then close that all up. Now, print is a built-in function that tells the program to display whatever you put into the parentheses. In this case, the quote 1 plus 2 tells the program to calculate what 1 plus 2 equals, and the sum will be printed when you open the log. So basically, if you put these little curly brackets on, it's telling the program when it runs, it's telling it to execute this first and then print what's inside the quotation marks here. Alright, so a value is the information that your program uses to operate. Examples of a value are the numbers or text. Results, when an expression executes, then outputs a value, then that value is the result. To evaluate is to execute an expression in order to produce a value. Note that evaluate and value come from the same root word, blah, blah, blah. Again, this is getting basic on you. They go through the operators here, which are the symbols like operation. And then here's something that we need to stop at. Parts of an expression. You learned earlier that an expression is the smallest part, or the smallest unit of code that produces a result. To expand this further, an expression is a combination of operations and values that output a result when evaluated. Here's how you can use what's called an if-else expression. So now this shows us that they have if-else statements here. And this is how you would write it here. So if you need to write an if-else expression, you would write if space parentheses. This is what you've declared already. And then you can go ahead and write your expression. It's going to print when if mice caught is greater than 0. Or else, basically, is going to print lose. So if mice caught is not greater than 0, then it'll print lose. That's what this is saying. The result is win or lose. This means that if one or more mice are caught, the player wins, or else no mice are caught, then the player loses. So that's what that says basically right there. Keywords. Some words are built into the verse language and have specific actions attached to them. These words are called keywords. In this example, if is a keyword and also else is a keyword. So is a keyword that meets, it's a keyword that means a condition must be met if the mouse is called. The other word else means that if the condition is not met, then there's a different result. So verse uses keywords to make writing programming easier. So much information on what programs should do is packed into each one. Keywords are reserved in the verse for specific built-in uses, so you can't use these keywords in other names and things. So let's look at some of these operations here. Here's the most common ones. Obviously, they're going to have way more than this, but these are the most common. An operation is an action or process that can be performed on data. These operations are represented by symbols called operators. The data, such as numbers, that an operator performs operations on are called operands. Okay? So the data is the operand, the operator is the plus sign. Or whatever sign you're using. So the first one we're looking at addition. The operator addition adds two numbers together. Obviously, subtraction. Operator subtracts the second number from the first number. Multiplication multiplies the numbers together. Division operator divides the first number by the second number. And here's one. The equality operator, it checks to see if the two things are equal. For example, if mice caught are equal to mice in area. If that's the case, then they want the cat to nap. Else, they want the cat to look for mice. And here's another operator here, query, which is a question mark. And the question mark checks if a specific type of value is true. So there's more operators, like I said, but these are the most common ones and a good place to start that they say. So here's some types and values. So far you've learned that a value is information that the program needs to do something, and the operators can be performed on this information. The type says what kind of operation the program can do on a stored value. Each type has a specific operations associated with it. So each type has specific operations associated with it, and those operations require specific kinds of values. So there may be different types, but below are the most common ones. So let's look at some of these. So here's logic, and this type is true or false. Okay, so this is like a bool. It can't be anything in between. It can be both, and it can't be both. If you've ever heard of Boolean logic on, off, or 0-1, this is the verse equivalent. So this is our bool right here. And in other coding language, bool can equal true or false, or can be true or false. So in this way, we're going to use logic in this one as bool, and that can be true or false. So just remember that. Int, this is what we're going to use for an integer, which is a whole number, not a fraction. And int is short for integer, so int means the value for this type must be a whole numbers, as you see here. Positive or negative. So examples of integers: 1, -30, or 777. Fractional numbers, you'd want to use what's called a float. This is the same, if you know Unreal Engine, this is the same knowledge. But you need to remember this part over here, because these are the parts we're going to use when we're using the verse language. So for float, we'll just use float. This is the type of values that are not integers, such as fractions. For example, 1.25 would take a float type value. It's called a float because it uses decimal points that is not a fixed, it's not in a fixed position, but instead can float to wherever it's needed in a string of numbers. For example, the following numbers are all floats: 10.25, 1.375, or 12.0. Note, 12.0 represents a whole number value. All integers can be expressed as floats. 1 would be 1.0, 777 would be 777.0, but floats cannot be expressed as ints unless they are integers. So just keep that in mind. It's basic logic. Here's another type that we can talk about here, string, that we'll probably be using. This is a type for any kind of text. Okay, if you're using text, you want to use string. This can be letters, numbers, punctuation, spaces, and even emojis. That's pretty cool. For example, modify and run your first. Okay, so in the little example they got coming up here, they actually do. They let us use the emojis. So remember that your string can be letters, numbers, punctuation, spaces, and emojis. Anything that you can type on your keyboard pretty much can be a string. Float has a decimal place in it. Integer is a whole number. Logic can only be true or false. Cool. Literals. A literal is an unchanging value in the verse programming language, like a number or another character. You'd only want to use literals when you know that the value will never change. For example, with the logic type, there are two literal possibles, true and false, because their values don't change. True is always true and false is always false. You'll learn more about literals and how to use them in the next lesson. So basically, they summarize it here. They say, when code is executed, expressions in the code are evaluated. These are keywords. These are like, highlights of the chapter. The evaluation produces a result. Keywords are special words in verse that have very specific actions attached to them. A value is information a program uses to do something. The type says what kind of operation the program can do with that value. Literals are values that don't change. So let's go into the next one right here. So practice time. Now, if you have not downloaded, Unreal Editor for Fortnite, go ahead and download it. Like for me, I'm downloading it right now, so I'm gonna cut this lesson right around here. But we can we can keep on going because there's certain things that we have to learn. So we can learn from this lesson without having to do all of the steps. When I do get my Unreal Engine for Fortnite editor downloaded, then I'm gonna go back and we'll do these steps in the engine, maybe, or we'll do some cooler stuff. But it's just cool to learn. Anyways, open your device, your Hello World device. So if you don't know how to do this, there's a link right here that shows you how to open it up and get your device into the project and whatnot. Basically, this lesson is teaching you how to print. So let's look at this line right here. When this line prints, what do you think will be executed first, right? Let's just think about it. So based on what we know, 5 plus -2 is going to be executed first. And the reason why I know that is because it's inside these curly brackets. So basically, when this prints off, this is going to give us 5 plus -2 equals 7, right? And that's all it's going to print. This one, what do you think is going to print first in this one? I'll give you 2 seconds. All right, obviously it's going to print what's in the curly brackets first. So 15 divided by 7. Now let's talk about this. This 15, this is a float. This 7, this is a float. This 2, this is an integer. 5 is an integer. I just want to make sure you guys are with me. You can also print, what is this here? This looks like a string. You see, these are strings. So it's asking it to print the string. And this, what do you think will print first? And what do you think will happen? It'll add I plus love plus you first. Or, I said you. I plus love plus verse first. And then it'll print off I love verse equals I love verse. You can also do this with emojis. And I thought this is really cool. I don't think I've ever seen this in any other coding language, but maybe. But yeah, emojis. Cool. Alright, and it's going to ask you, this is all the code. Okay, yeah. So basically that's the code. So let's look at this next lesson. That one was more so for practice, and if you have it already downloaded, go ahead and practice that screen. But I wanted to go onto this screen because this is where you're going to start to learn some heavy stuff where it's kind of a little bit different from blueprints, but I mean, if you know C++, it's kind of similar to that. But let's look at it. Programs need information to know what to do. Learn different ways to store information in your program. In Lesson 2, you saw some of the more common types of the operations and values associated with them. It's time to start learning how to use these types and values in your code. The values that expressions use are sometimes referred to as information or data. Programs need data to know what to do. And there are different types of ways to store data or values. All right, so let's look at the different kinds. So some data can be mutable and some data can be immutable. What does that mean? Mutable means capable of changing. Think of a mutant, right? Someone who uses whose DNA code has changed or mutated. Mutable, can change. The waves along the shore are mutable. Okay, when something is immutable, it cannot be changed. Like they're trying to say, like, okay, if you don't think about the earthquakes, the tidal waves, explosions, or erosion, the cliff overlooking the beach here would be immutable because it doesn't change. So mutable means it can change, immutable can't change. But what does this have to do with code? When a value cannot be changed while the program is running, it is immutable. If the value changes while the program is running based on input from somewhere else, the value is mutable. Verse comes with built-in types that support basic operations that most programs need in order to run. These built-in types are the foundation for using variables and constants. Now, this is where we got to talk about some variables and constants here. Again, if you know Unreal Engine, you've used variables and you use constants, but you haven't, if you use blueprints, you haven't typed them out like we're about to do right now. So in programming, you use variables and constants to store values that your program uses. So these are ways to store values, okay? Like containers. Think of them as containers. When the program needs data to determine what happens next, the computer's calculations and decisions are based on the values stored in the variables and constants in the code. Cool. Although the term variable sometimes is used generically to include both variables and constants, there is one important difference, okay? The difference is variables can change their values while a program is running, but the constant values cannot be changed while the program is running. In other words, the value for the variables are mutable, while the value for the constants are immutable. Value for variable is a hard thing to say. Value for variable, value for a variable. That's a tough sentence. Sheesh. Anyways, syntax for variables and constants. Okay, this is important. Whenever you write code, whenever you switch from one language to the next, you need to be very, very conscious of the syntax. So when I write C++ versus when I write Python, there's real slight differences there, and you gotta know it. So now we're learning a different language. This is called verse, and the syntax goes as follows. So here's the syntax for a variable. First you'd write var, and then the name of your variable, then a colon, and then the type of your variable, equal sign, and then the value of that variable. So the var at the beginning of the line shows that it's a variable. The basic syntax for a constant is just take off the var. Instead of having the var there, just do name, colon, type equals value. Note, the only difference in syntax for a variable and a constant is the var is removed for a constant, but included in a variable. So let's look at, now to unbox what the syntax says. So basically, let's look at what this is trying to say to us. So we know that var, this first part is telling us that this is a variable. If it wasn't there, it would be a constant. So this next part, name. The name is a unique name the programmer gives to this variable or constant. Remember that var is not part of the name, but only indicates that the variable it is a variable and not a constant. When you want to refer to this variable in the program, the name is what you will use. So this is what we're going to name our variable. So you'd have, if you like, when you want to call this back in your code, we're going to refer to this name to call it back. All right, the type after the colon. The type explains what can be done with the value in this variable. And note that a colon separates the name and the type. You have to always keep this same structure when you're writing this code. Now we just went over a few different types like the float or integer or logic. That's what the type will, that's what literally will be written here. Those types that we just went over. And I'm sure there's other types, but those are the most common ones that we just talked about. The string too. I didn't say string. But this value right here, this is the data. So for a constant, this value will remain. Well, oh, they're trying to make a joke here. Well, constant. For a variable, the value is going to be variable. It starts with, so, all right, the value. If this is a variable, then this value here is going to be what the variable starts with, okay? So it's like, if you're using blueprints, it's like initial value, or yeah, it's the initial value of the variable. If you're using a constant, this value is just the constant, okay? Yeah, it's the initial value. Same thing in the blueprints, guys. If you know blueprints, yeah, you know this too. But this is the initial value. Note that an equal sign separates the type and its value. Setting an initial value for a variable is optional, but it's good practice to do so. Now, there are going to be some cases when you don't necessarily want that to be the case. You want it to start from blank. But they just said it's good practice to do so, so we'll follow the good practice. Setting the value is required for a constant, though. Okay? So if you're making a variable, it's not required to set the value, but if you're making a constant, it is very much required to do so. So let's look at some other things. All right, an identifier is the unique name a programmer gives to an expression. The words identifier and name are synonymous. So, identifier, name, synonymous. That means they mean the same thing. Okay, naming rules and conventions. There are rules for naming things in verse. When creating variables and constant, keep these naming rules in mind. All right, these are important. As much as possible, give your variables and other expressions names that indicate what they do. It's good practice to name your variables in a consistent way that will make your code easier to read by others and easier for you to remember. The first character in the identifier must be either a letter or the underscore character. Characters past the first character must be letters, numbers, or the underscore character. So the first character can't be a number, guys. It has to be a letter or an underscore. But any character past that can be a number, underscore, or letter. You can also have more than one underscore in the name, or even two or more underscores together. Neither variable nor constant identifiers can contain spaces, okay? So if your variable that you're making is chase player, right? You cannot put a space between chase and player. That variable has to be called chase player. You know what I'm saying? Verse is also case sensitive. So remember this. This is very important. When you're writing stuff, it's case sensitive. So it's important to be consistent in your capitalization. If you're not, this will cause some errors in your code. So for me, coming from blueprints, now this is something I'm gonna have to pay very close attention to. Capitalization. Come up with a convention. So this is pretty much how they're teaching you to do it. All right, so let's look at declaring a variable. Each variable or constant has three basic parts: an identifier, which is a name, the type of value it can store, and the value itself. So here's the example of what it would look like in your editor, your Visual Studio Code. It will look like variable, or var, space, name, space, colon, space, type, space, equals, space, value. In verse, you can create a variable by declaring it. To declare it, the variable must have all three parts. And, when it needs to have the identifier, it has the type and the value. So it has to have this, and this in order to be declared. Initialization, setting an initial value to a constant or any other expression, and is called initialization. Initialization is required when you declare a variable or a constant. So if I'm saying chase player equals true, right? Then I just declared, the initial value for chase player is going to be true. So I just declared that the initial value was true. And with this colon equals operators, you can initialize values in a constant. So basically, coins is the name here. Colon, it's an integer, and the value is 500. Note that with this operator, the name goes before the colon, the type goes between the colon and the equals, and the value comes after the equals. Using constants effectively. When you have a value that shows up in multiple places in your code and that never changes, it's smart to make that value a constant. Okay? Remember literals from earlier? A literal is a value that never changes. Ideally, you should use literals sparingly. For example, if your game lets the player buy a mousetrap with 100 coins, you could write the literal unchanging value 100 into the program wherever the code subtracts from coins when the player buys that mousetrap. Or this is just like blueprints, yo. If you know logic, you just gotta learn the syntax. Or when the player buys and is mousetrap better, you could declare and use a constant like coins per mousetrap that holds the value 100. Okay, so basically they're saying you could either subtract a constant value from coins every time they buy the mousetrap, or you can declare a variable called coins per mousetrap that holds the value that, so it'd be like, oh, here it is, coins per mousetrap, integer 100. Wow. Using constants in this way makes your code easier to read for both you and your teammates. In some cases, it returns later to modify, in case someone returns later to modify the code and hasn't been able to touch it in a long time. Your code will also be easier for other programmers to understand when you use well-named constants instead of unexplained literal values. Another advantage of using constants in this way is that if you decided to modify a value, such as how much a mousetrap should cost, you will not only have to update the constant, not every single instance where that value is used. Oh, you would only have to update the constant and not every single instance where the value is used. And that's how I actually do my games. So it's like you're not about to update all the values, just make the parent pretty much do it. Use clear names for your constants when possible. The example, coins per mousetrap, clearly represents a constant for the number of coins the player will spend to buy a mousetrap. When you have a value that will not be changing, store that value with a constant. Alright, let's move on. Assigning a value to a variable. Ooh. Unlike constants, variable values can be changed while the program is running. Constants save you from having to enter the same value over and over, but what's the advantage of using a variable? Well, sometimes you want to be able to change the value based on some other input. For example, when the player buys a mousetrap, you might want to use this line of code to subtract the number of coins the player spends on a mousetrap from the total number of coins the player has. Set coins equals coins minus coins per mousetrap. So this is a way you can use variables, guys. Let's break down that line down. So the first part, set, is a keyword built into verse. So if you're like taking notes or whatnot, it's like set is another one you should write down along with the types. But this is a keyword, which if you use blueprints, you're pretty much familiar with this. Keyword set can be used to change a variable's value. So this line of code is saying that coins can be changed to equal the value of coins minus coins per mousetrap. So that is saying that the coins, this is variable, and it can be changed based on their coins minus coins per mousetrap. Okay, the change of value using set can only be done with a variable. You cannot use set with a constant. It's pretty important there. Both coins and coins per mousetrap in this case would be identifiers for expressions that already exist in the program. So remember what identifiers are? They're just names. And expressions are this. You know what I'm saying? Lines of code, simple executions. Summary. Variables and constants are both used for storing values. The primary difference between the two is that value for a constant can't be changed while the program is running, but the variable can be. Variables and constants are expressions that produce results when evaluated. Variables and constants are declared in verse. This is done by giving the expression a unique name or identifier, a type, and a value. So, in order to declare your variables or constants, it needs to be declared in this language verse. When you set an initial value to an expression, this is called initialization. And that's pretty much Well, you got practice time here. So now, this is what you want to do. So if I were you, I would open up my game and let's go ahead and go over this screen on your own. I'm gonna leave you on this lesson 3 practice time because I'm gonna come back tomorrow or whenever, and we're gonna go over writing simple code in lesson 4. But this is a good place to stop because this is pretty long. But if you want some practice, practice through all the practice times. There's a few practice times that we skipped, and if you want to go ahead, go ahead. You know what I'm saying? It's all here. But I'm doing this so that I can learn verse. That's very simple. I hope y'all are learning it too. But I'll holla at y'all next time. Peace.